Welcome back. This is Problem 52, Chapter 2 from OpenStax College Physics. An object is dropped from a height of 75 meters above ground level. Determine distance traveled during the first second. Letter B, determine the final velocity at which the object hits the ground. And letter C, determine the distance traveled during the last second of motion before hitting the ground. So let us try to take a look at this. Um, let me draw the ground as a reference. Okay, this is the ground. Okay, great. Now, the object must be somewhere here at the start. Let me do it in blue. 75 meters above the ground. Okay, that's 75 meters. Let me put also an axis here, just to denote at least we know the what? At least we know the height. Okay, so at the start, here it is here at 75 meters. Oh, that's too small. 75 meters here. Okay, that is at the start. Now, determine the distance traveled during the first second. So, well, for this case, what do we know? What do we know for this scenario? Now, this is under free fall, meaning it's only gravity acting, and by that we know that A will be, if we assume upward positive, okay? Assume upward positive, A is negative 9.80. I'm just using 9.8. Some use 9.81, but it's the same thing as long as you're consistent. Negative 9.80 meter per second squared. Okay. Now that's A. Now, what do you mean by this? As the ball, that's A always. Now at this point, I think it is clear that V of the ball here at the start is zero because it's just dropped freely. Okay, it's not being what thrown downwards. So V initially is zero, and during that time for part A, let me work into that. For part A, so we're looking for the distance traveled during the first um, 1 second. So we're using, I think it's good to use equation 2 here. S is equal to VOT plus 1/2 AT squared. Plugging in values, VO is 0, so it will just be 0 plus 1/2. A is negative 9.80. T is 1 squared. So I'm getting a what? Negative, what will that be? 9.8 divided 2. So it's 4 what? 4.9. 4.9 meters. The negative sign simply indicates that what? The negative sign is displacement, meaning the particle has moved downward. Okay? So the particle is somewhere here. Okay? Where this point is some things like 70.1 meter, right? Because the particle is now here. Okay, after 1 second. It's moved down by 4.9 meters. So the answer for part A is really, of course, the answer will just be 4.9 meter. The negative sign again simply indicates that it's moving downward. It's S here is displacement anyway. We're only looking for the distance. Now for part B, determine the final velocity at which the object hits the ground. Now this is interesting. We're looking for when this object hits the ground, what is its velocity? Okay? Well, um, I think the best equation to use here is just equation 3. Why? Because we already have S, we already have VO, and we have A. We can solve for VF. So for part B, let me have that here. For part B, we can just simply use 2, and A again is negative 9.80 downwards. S here. S for this case, I'll just say it's negative 75. Why negative 75? S is displacement in terms of final minus initial. Final position, let's height of 0 minus initial position height of 75. So yeah, it's negative 75 there, equal to velocity final squared. That's what we're looking for, VF, minus velocity initial squared, 0. Therefore, from here, I think it's clear that VF is equal to, oh, VF. So let us see if we can solve for that. 2 times 9.80, okay, times 75, okay, and I take the square root because that's VF squared. Take the square root Oh, it's 38.34. Now plus minus 38 point um 34. Now the idea here is that, of course, we're choosing the proper thing to choose is really negative, because we're assuming that downward. So meaning the velocity here, it means what? 38.34 meter per second downward. Okay, the negative there simply indicates downward. Note that we can have two values, a plus and a minus, because we're taking the square root. But of course, we're taking the negative one because we have an idea that the ball must be moving downward at that point. Okay, and lastly, determine the distance traveled during the last second of motion. So what is that? The last second of motion. Oh, it's an interesting last second. So I think it's proper to calculate first how long does it take, the time it take from this ball from 75 meter to reach the ground. So how do we solve for that? We can use this final velocity to solve for the time. Yeah, I think we can use that, or we can use this equation here, S is equal to VOT plus 1 half AT squared, to solve for the time. No matter, I think we just use this one. It's up to you really. There's a lot of equation to choose from, but I'm using this. I'm not using this result because maybe I made a mistake on VF. So I use the equation for this one. So if I'll use that, let us see. S, it's negative 75 because it's moving downward. Displacement is downward. VO is 0, so that's 0 plus 1 half. A is negative 9.80 t squared. And therefore, from here, I think one can solve for t equal to what? Let us see. Multiply both sides by 2, so that's 75 times 2. Divide by 9.80. Divide by 9.80. Okay? And take the square root. Take the square root. It's 3.921 seconds. I'll have 3.912, okay? 3.912 seconds. Of course, you can still I think you can still get the same thing if you use this equation. You use VF and VO, right? Using this equation here for the first one, let us just try to show if we can get that. VF is negative 38.34. VO is 0. A is negative 9.80. T squared. And I think the same thing, right? 38.34 divide 9.80 and take the square root. Uh-oh. I know. There's no square root. There's no square there. Just t. So you don't take the square root. We get a 3.912, the same thing that we get using equation 2. Okay, so this is the time. So I think the best thing to do here is what is the thing that how far determine the distance traveled during the last second. Meaning that last second means it is what? The ball is somewhere here at t equal to 2.912 seconds, and the ball is here already at the ground at 3.912 seconds, which means that we could what? We could, I think we could just solve for the how far downward has the ball starting from rest with this t equal to 2.912, right? So let's solve for that. How far does it move downward? So S is equal to, we'll use that equation here. Let's use in blue. S is equal to VOT, that's 0, 0. We start from here, okay, until we reach that, plus 1 half. A is negative 9.80 times t squared, 2.912 square, and we're getting an S equal to, let me see, what's the value best that will I get? 9.80 times 2 times 2.912 square. Yeah, 9.8 times, oh, why I'm multiplying by 2? It should be divide by 2, right? Yeah, on divide 2, divide 2. I hope you understand why I'm doing that. So the answer is 41.55. Okay, negative 41.55 meter, meaning it has what? It has, moved down by negative 41.55, meaning it's moved by that. So meaning if this is 75 here, drop by 41.55, the new location will be, okay, minus 75. Please, it will be 33.45. 33.45, right? I hope you agree with me that if you start from 75 meters and you drop, meaning the displacement is negative 41.55. Note that displacement is final y final minus y initial, meaning location final respect to y minus location initial. And location initial is just 75 meters. So y final will be 33.45 meters. So if you'll be asked, how, so I mean, that is the location here, 33.45 meters. So after 1 second, it will be at the ground, which means the answer for part C is simply 33.45 meter. That's the one. That's distance covered by the ball and in the last 1 second. Note that in the first second, it has only traveled by how much? In the first second, only traveled by 4.9 meters. Quite a small drop. But in the last 1 second, it's now able to travel at 33.45 meters. That's quite fast already, right? Of course, that makes sense because when it reached the ground, its speed is now at 38.34 meters per second. Thank you.